All right, today's lesson is simplifying radical expressions. So, what is a radical expression? It's a number that can be written under a square root, right? Or under any type of root. So, here's my first example. Let's say we were to simplify the square root of 98. Okay, the square root of 98, if you type it into Desmos, and most of your work, I recommend use Desmos, all right? So, Desmos tells me this has a value, this expression has a value of 9.89, blah, 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 a lot of nasty, ugly decimals. And my job is to simplify it, to write it in a more simple way. So your first rule is you can actually factor radicals. So if I could write a rule, it would be this. The square root of a times b is the same as the square root of a times the square root of b. I think I have it written somewhere. Okay? In other words, you can factor a radical expression. So here I go. I'm going to factor the radical expression root 98 into the square root of 49 times 2. Okay? So that's the square root of 49 times 2. I double check. That still has a value of 9.89 or 9.899. Okay? So far so good. Now, I have right here in the notes, not only should you factor it, but you should also make sure that your factor includes the largest possible perfect square in the factoring process. So I know that there are multiple factors of 98, but 49 and 2 happen to be the very best pair. All right? Why? Because the square root of 49 is actually a perfect square. All right? The square root of 49, many of us know, is... What is the square root of 49? Oh, 7. It is 7. Okay? The square root of 49 is 7. Therefore, you can rewrite in the following way. Square root of 98 equals the square root of 49 times 2, or isolated radicals, the square root of 49 times the square root of 2. That's the rule. And finally, last stop, 7 square root of 2, because the square root of 49 is equal to 7. That is how you simplify a radical expression. Simple as that. So, what is going to be useful for me? It's going to be very useful for me to know my perfect squares. If I were you, at the top of my page, I would write all my perfect squares. What are my perfect squares? 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and 225. Okay? Those are your list of perfect squares. I'll come back to it here in a second. Okay? So, how is this useful? What if I want to do a little bit more? What if I want to do something like 4 times 8 times the square root of 200? Let's see some of those skills that we've learned. Well, 4 times 8, we know, is 32. All right? So you could start there. You could also start by simplifying your radical. So I'm going to factor the square root of 200 into the square root of 100 times the square root of 2. All right? The square root of 100 times the square root of 2. And I double check that I did my work right by seeing that I have the same value. Okay? Now, again, 4 times 8 is 32. I like to have large perfect squares as my factors because I can simplify them. What's the square root of 100? 10. Okay? So I end up with 32 times 10 times the square root of 2. The square root of 2 cannot be simplified anymore. It does not contain any perfect square factors. All right? That's how you know you're done simplifying. So last thing, 32 times 10 is 320. All right? What's my rule there? That coefficients outside of radicals can be multiplied or divided to one another. And radicals can be multiplied or divided to one another as well. Let's see that in action. If I were to take the square root of 180 and divide it by the square root of 9, I can simply divide those two numbers because they're both radicals. Now, if one of them were a coefficient and one a radical, I would not be able to combine them or to divide them in any way. However, square root of 180 divided by square root of 9 is equal to the square root of 180 over 9. In other words, that's the square root of 20. Then I can go back to my first lesson, factor the square root of 20, which is the square root of 5 times the square root of 4. I chose a perfect square right there. So square root of 4 is 2. Final answer, 2 root 5.